All right. Quickly on agenda, I'll just introduce myself. Brent Mason, founder and CEO at Citizens Consulting Group. I've been doing Power Platform and Power Automate development for about 5 years. Going on, almost 20 years ago, maybe more than 20 years ago, I worked for KPMG, did a lot of project management and business analyst work for them up and down the West Coast, and I've learned a lot of stuff with that. And yeah, I've been leading the Citizens Consulting Group for just over a year now and working with a lot of great customers, a lot of great folks. And I did want to give a shout out to all my friends, students, employees from Grenada who are attending. I saw at least 3 people that are on the call from the Caribbean island of Grenada. So welcome, guys. All right.
We need to do a field trip there soon, hopefully.
Yeah, hopefully maybe in February. We'll see. You know, I'm gonna wait till the hurricane season is pretty much over. Last year they got walloped pretty hard by the first hurricane of the season, which is pretty sad. But anyway, we'll talk about happy stuff today. So just by way of the agenda, I'm going to talk about what's the problem with polling and Power Apps? How do you get real-time data in there? Talk about the use case I have for today's presentation. We'll go over the architecture. We'll take a peek at the different code repositories that I put together. We'll do a quick demo, talk about some lessons learned, talk about how we can use this in the real world, and then wrap up with some Q&A and possibly an experiment if we have some time to see how much stress we can put on the system. So I'm going to jump right in here and flip to the next slide. There we go. All right. So, one of my goals before I even started thinking about this presentation was, how can I get real-time data into a Power App? Because there's a lot of different data sources out there, but none of them are really real-time, right? You can put data in SharePoint, and then you can surface it in a Power App. You can put it in Dataverse. You can hook up other data sources to Dataverse, and and have Dataverse be the middleware. But there's always latency in there, and sometimes it can be pretty quick, right? But you make an API call every time you call a Power Apps connector, right? Effectively, you're calling an API, and you're really dependent on how responsive that other system is. I'm going to guess one of you or more of you, when you've been using a Power App or Power Automate, particularly on Power Automate, you click that button, right? And those little dots start going across the top of the screen, right? And you're going, okay, what's going on? Or the spinner's going around, and you're trying to figure out, why is it taking so long? And when you need to get data quickly, that's just not a good way to keep yourself refreshed on a regular basis. You can do it with polling, right? You can take and put a timer on your Power App, and every so often, every second, half second, how fast your API can handle it, you can go out and try to get fresh data. And sometimes it's fresh, sometimes it's the same data that was there last time. There's a number of different technologies you can do that, but doing that, it puts a load on the API, right? Every time you call it, it has to process and respond. And a lot of APIs, in fact, just about everyone I could think of as commercial, they do have rate limits, right? You can't saturate the subscription with this. And if you get too many people trying to do that, right, everything slows down. So the other thing I tried out as part of where I went first was webhooks and subscriptions. But unfortunately, there is no endpoint for the webhook to subscribe to so that a Power App can get the data. So that wasn't going to work. I actually you'll see I spent some time, getting my API to work with webhooks and subscriptions. And when I got down to actually use the API in the app, there was no way to do it, right? You can have Power Automate. You can call Power Automate, which can subscribe to a webhook, but then you got to get the data back in to the Power App. So there's a question about how do you get that in a timely manner? And why is it a problem? If when seconds are okay, right? Well, you can live with that. But in my race car use case, right? Well, milliseconds, right? If there's something going wrong with the engine, you want to know right away. You don't have to wait 2, 3, 4, 5 seconds, or maybe a minute for something to get back to you. There is a cost associated with polling and other technologies in that you can only have so many calls to a Power Automate flow. depending on your license, and Dataverse storage, a number of different things. And as I mentioned earlier, API rate limits. So that's some of the challenges that I was looking to overcome with kind of my proof of concept for this. So next, I want to talk about the use case. So I was like, well, what are some good ways? What are some good reasons that I would want to get data really quickly? And honestly, the first thing I thought of was a race car, right? Because if you're an engineer or mechanic, right, and you're watching your driver going around the lap in Indianapolis 500 or stock car racing, right, at 200 miles an hour, you're going to want to know what's going on. So I took and developed an API that will stream the data. It will take and stream the speed of the vehicle, miles per hour, the RPM, engine temperature, lap position around the track. I also have control points where I can manually move the throttle up and down to go faster or slower. I have a toggle which will turn on an autopilot as opposed to me manually doing it. I can also take and click a toggle in the Power App and trigger a cooling system failure. The API itself was written in Go. I didn't try to write an API in a Power App, seeing you can't get data in from an external source, like you can other systems. I use Golang as my opportunity to do that. All this is running on, at least the API portion of things, on a Raspberry Pi 5 with 8 gigabytes. And I don't know if you can see my screen here, but this is about the size of a little bit bigger than a deck of cards. If I take out the case, you can see here's a little single board computer, 8 gigabytes, runs 4 cores at 2.4 megahertz or gigahertz. It's amazing what these little guys can do. So this is where the actual API is running. And I'll show you how I used some Swagger support to actually writing the custom connector to send data from the Power App or my controls from the Power App back to the API. It's super, super easy to do. If you guys have ever tried to create a custom connector, you know that if you don't have good Swagger support, it is a pain. I mean, it can be done, yes, but it's a challenge. So, why was this a great test bed? Continuous high frequency data. Needed low latency, when milliseconds matter, and easy to visualize, right? So something you'll be able to see. Now, I don't have a lot of race car gauges and dashboards and all sorts of super fancy stuff. I thought about doing that, but I really got down to, what happens behind the scenes is the numbers and the data. So that's what I really focused on, rather than trying to make something that was shiny with lots of bells and whistles and flashing lights and things like that. So I guess any questions anybody has before I move on to the next slide where I kind of review the architecture?
Pretty slick so far.
All right.
Any questions? I did mention in the chat too, if you have questions that come up, please don't be bashful. Love to make your time as valuable as possible for being here.
Yep. Cool. All right, well, we'll take a little look at the architecture before we jump into the demo here. And let's see here, see if I can do a cursor. Can you guys see my pointer on the screen at all?
I can see it.
Okay, yeah. All right. I'm learning something new every day. I've never done this stuff. So in the back end, right, this is where I have the Golang API that's running on the Raspberry Pi. So this takes requests for information, and it also sends out data via the stream. So the way the data flow works is there's a PCF control, which basically latches on to an SSE, server sent events, right? If I got that right, yep, server sent events. I got my cheat right over here on the other screen. So we have that, and there's an endpoint on the API called /stream. And there's a PCF control, which is the custom control that I built and imported into the Power App. And I simply take the URL of the stream and put that in there, which I'll show you. And suddenly, using the on change event of that PCF control, every time data gets sent, the Power App updates the data, as you'll see in a data table, in real time. right? And at the end of the session, if we have some time, I have the it updates once a second right now, because if it goes too fast, you can't really see what's happening on the screen. So I kept it down. But I'm gonna, if we have time, I'm gonna take and crank that up and see how fast we can get it to go. And you guys could actually all subscribe to the stream, and we could see what it takes to bring the Raspberry Pi to its knees, if we can. I have doubts we have enough people on the call to do that, but yeah, we'll see. All right. And so that's what's inside the power out. There's a custom connector that I also built, which I'll show you how to put that together using the Swagger. Super easy if everything goes as planned. But I use that to toggle things, as you'll see inside the app. And that sends the data back to the API endpoints to set things like the throttle level, simulate a cooling system failure, which then the API gets that, and it just kind of goes around and around and around. All right, and I don't know the answer to this, but 2 points for anybody who can identify what kind of car is on the screen right there. So, you guys know what that is? Go ahead and just
is it a Shelby?
I have no idea. It was just a stock
that is
picture.
A fast car.
Yeah, Shelby Cobra looks like.
Is it? Okay, so I'm not crazy. Love it.
All right, somebody knows the cars better than me. All right, so I'm going to talk about the demo here just a little bit. So first thing I'm going to do is show you a little bit of Go code. This is pro code stuff. I'm not going to spend a lot of time on that at all. I'm going to take a little bit of look at the PCF code. Once again, I wouldn't call myself an expert PCF developer yet. We'll talk about that. We'll go review doing the custom connector. Then, kind of as the climax of the demo, we'll actually go in and look at the Power App and watch all this stuff go together. So with that, I'm going to take and switch over to my other screen, and hopefully everything will go well. And then we'll come back to this Power App presentation in just a minute. All right, let's see. Let me move this over there. All right, can everybody see the Wikipedia entry here?
Yep.
All right, awesome. So I just wanted to, SSE server sent events, been around since 2004, 2006. So not a new technology. One of the things I like about it is it's available in all the modern browsers, including Edge, right? Firefox, Chrome, Opera, Safari, Microsoft Edge. I'm sure there's a few others that aren't listed here that where this is done at. All right, so I'm going to bring up now VS Code, and first I got to switch to my code base here. So bear with me for just a second, and we switch over to the Golang. And I don't know, for those of you guys that have really good eyesight, you can see that originally I started this as a webhook proof of concept, because I thought, oh, webhooks, I can subscribe to webhook from a Power App. Well, wrong. It doesn't work that way. But I did take and, just decided not to rename things, just to keep things going once I got stuff working. But I don't know, there's in the whole API with everything, about 700 lines of code. I'm not going to tell you I personally generated every single line of code here, but I did put a lot of it together, and enough that I definitely understand what's going on, because I've written an API before. A lot of the code is really about the engine simulator, right? And I really don't care whether the physics are perfect or not. It just get the simulation to give me what I wanted. But the things I do want to take and show you here here's where we have all our API endpoints, right? I have a way to subscribe to the webhook, unsubscribe. There's a state, which I'll show you, which just basically gives you a point in time JSON data of how the race car is doing. I can take there's an endpoint to simulate a failure or the cooling okay. So with the failing and the restoring, a way to turn the autopilot on and autopilot off, a way to set the throttle, and most importantly, the streaming component of it, right? And once again, not to get into all the details of the Go code, other than to say that I'm going to scroll down here, and at the top of each handler, right? So each API endpoint is this set of code right here. These are just comments, but if you put these comments in properly, your Swagger component, right, can actually read these things. And by doing this in front of each one of the API endpoints, it makes making a custom connector so easy. I mean, I'm talking like when I got it working, I was like, oh my gosh, that's all there is to it. This actually worked. I was floored. I just didn't think it was going to be that easy. I thought I was going to have to do a lot of manual configuration in the connector. Didn't have to do that. I'm just going to scroll down here towards, I'm going to skip through all this here, just get down to the bottom. There's an engine simulator loop, which is a bunch of physics gobbledygook, right, which I really don't care about. But what I do care about is simply the stream handler. This little set of code right here is all it really took to implement the server sent event stream, right? And the key line here, which we're going to play with later, is the ticker, right? Which right now is set to once every second. We're going to decrease this number and see how the API and the Power Up handle it when we continue to increase the frequency of the updates. So once again, this is all in Go. I know that we're not a Go user group here today, so I'm not going to go into the details, but I will ask, does anybody have any questions about the API portion of things before I jump in to the PCF control portion of things?
I don't think so.
Okay.
I think, I mean, just overall, even though you're not like a Go expert, being able to use AI to build like an API, right, like is kind of the moral of the story.
Well, you can do that, right? I mean, I like any kind of what I'll call vibe programming. Like if you have no idea what you're doing, when something doesn't work, you can't fix it. So, some people are good, better at vibe coding than maybe I am, but I like to understand the code that I'm writing, right? So I could say that, yeah, I could definitely understand and fix errors in everything that's here.
Gotcha.
So
Gotcha.
I wouldn't suggest somebody start a brand new technology, particularly if you're a beginner, using vibe coding. Not that you can't, right? But it's fraught with challenges when there's a bug, right? First 2 or 3 iterations, it works great, and then it kind of starts falling apart from there. So just be aware of what you're getting yourself into when you start going down that road. All right. And then again, and this is where I will confess, I'm not a PCF expert. There are plenty of videos out on YouTube about how to write a PCF component from scratch. And that's basically what I did. I started watching 2 or 3 different videos, got the idea of what's going on. And there are two, from my perspective, 2 major files, right? There's the control manifest input XML, which is this file we're looking at here. And really basically it says, hey, for the control that's going to get embedded into the Power App, what are the inputs and outputs? You have to put together a namespace when it's in some pro code gobbledygook jargon, right? But the key things are here. We have 2 properties. There's an input property, which is saying, hey, what is the URL that this component needs to connect to? And what is the output of this going to be? All right, in this case, the output is going to be a single line of text. It's going to be JSON data. And then going over to the TypeScript file. Again, I am not an expert in TypeScript, although I play one on TV and in users groups. But what I can tell you is, the main function, this init function, is where, things get set up, get put together. You can see it creates some divs that the custom component uses, chooses some fonts, some colors, some other text that gets put in there. And then there's some code that's saying, hey, what happens when an update happens? What do we do to connect to the stream of data, which is right here? What do we do to get the disconnect, right? And then how do we handle the IO? And then last of all, when you have a init, right, in an object-oriented language, generally you want to destroy what your stuff, what your objects are that you created, and have this great command called this.disconnect, right? And so this is where it kind of ends at that. There is a number of steps you have to go through to create a PCF component. You've got to download some PowerShell scripts and tools for the Power Apps portion of things. I'm not going to get into that, as the plenty of YouTube videos that cover all that. I'm happy to answer questions about how I did it. And I give you some recommended viewing if you are interested in what I watched to kind of make this happen. But again, not going to spend too much time looking at this portion of stuff. I am going to now take a moment. Let's see. So we looked at that, and I wanted to look at the custom connector that I did for this. So I was going to take a moment and share that with you. But before I did that, I want to give you guys just a quick look at a few things that are going to come into play. So I'm going to put this into chat. So anybody on your browser, there's no authentication necessary for this, but if you take and use the URL I just put in there, it will take and it will give you the current state of the race car engine. I'm going to zoom in on this just so we can make it bigger. All right, and I'm going to just hit the refresh button here. It's going to spread things out, but you'll be able to see the speed. You can see every time I press refresh, right, these numbers change. Right, even as fast as I click it, right, it comes up with the data, giving me the state of where things are at, every so often. And you can see here we actually have the UTC time down to the second. I'd probably get more resolution on that I want to, but make it pretty again. Now, super cool thing, remember I showed you in that Go code. I'm going to flip back to the Go code just for a second. And let's see, go back to the... Let's see here. Yeah, that's it. Yep. Okay. Remember, I talked about these comments up here and how it supports Swagger. So if I come over here, right, and I look at this, I'm going to go back to a little easier to read here. You can see here are all my API endpoints, right? And all I had to do was just go to the citizens consulting group.com/swagger/index and HTML, right? And you just really have to just go like this, right? And boom, and there it is. And here's all the information, right? And this is all the stuff that the Power Apps custom connector really wants to know about, right? These models in here about what happens, what schema is it? If I want to, I can hook up to this, right? And I can say, hey, I'm going to try out, I'm going to simulate a cooling failure. And I click on this, right? And if I did this right now and we were running the Power App, you would see that it would show a cooling failure happening, right? I'm going to clear that out. I'm going to close this. I'm going to restore the cooling system. Try it out. Let's look at execute, right? And execute that. And now it's been restored. But it has response bodies, all the HTML stuff, HTTP stuff that you need to work to handle that. And yeah, nice thing is if you use Swagger, all this stuff works like almost automatically. If you want to see what the actual stuff you put into the custom connector, this is all the stuff you put into the custom connector, and you can get that just by going Swagger JSON doc, and I'll show you how we're going to do this. So this is the working connector, right? And so all I did is I took my host, my PA1.citizens consulting group, drop it here in my base URL of root. I did set up an HTTP or SSL cert on this, so we are HTTPS. I did not put any security on this, right? I figured why deal with authentication? It's a proof of concept. We're trying to make this thing work, not show that we can get through a login process. Here you can see that all the definitions are set up and all these cooling fail, all this matches the Swagger. I'm just going to click back and forth real quick so you can just see what cooling failure, restore, auto on, auto off, right? Right here, right? Cooling failure, restore, auto on, auto off, slightly different order, but you can see all of these things here are shown in the custom connector, right? And then there's some code that happens if you want to test stuff, and then you can test it out. But I want to actually show you how we can take, and I'm just going to duplicate this, show you how we can make our own custom connector, and I'm just going to start back from connectors. All right, let's skip all that and show you guys how easy this is. It's going to take us a couple seconds for load. While it's doing that, I'm going to go back to my first. I'm just going to grab this URL and copy this. And pop back over here. Okay. And I don't want a new connection. I want a new custom connector. Oh, and that's what I need. I'm sorry. I need to go into my solution. See if I can get this to work right. Okay. And we have a webhook POC. All right, so I'm going to say new, and I'm going down here more. I'm going to say, let's see, other, where am I missing? I'm missing, there's a custom connector here, connection role, connection reference. I always make this a custom connector. So there's my one custom connector. All right, going to go outside this again. Let me go back. Connections. over here. Connection. All right, now I'm gonna have to get help. Get ChatGPT to help me out here. Connection machines, discover all. I swear I was here a minute ago. All right, so when all else fails, right? Google it, right? How to make a custom connector.
This is why we love live demos, right, Brent?
Oh, it's okay. It's one of these things where it was working great. Let's see, Power Automate, right? Okay, connector name and new custom connector, right? Or your custom connector and create from blank. Select solutions. Okay, so we did that. So we'll go back here and I'll go to solutions and we'll go to my solution. Okay, we'll put POC. Hiding down here. No, okay. So new. It's under automation, custom connector. There it is. Okay. Yay.
Woohoo!
Yeah, tell me about it. All right, we're going to give it ourselves a name. We're just going to call it PPUG connector. All right, and I take the endpoint I put in there earlier. I'm going to stick it right here, and I'm going to skip on the description, icons, and things like that. Security, good news is no authentication. All right, now we're at the definition. So I'm going to go to my Swagger editor. I'm going to turn on my Swagger editor, and notice it has this stuff in here. Well, not helpful. There's nothing to authorize. Like, what do I do? Well, this is when you go to your Swagger UI, right? And then, as I mentioned earlier, if you simply type swagger/doc.json, you get this big file here. So I'm just going to say Control A. I'm going to copy all this. And I'm going to go over here to my custom connector. I'm going to replace all this code here. I want to convert it to YAML. Sure, whatever, right? So now it's all in YAML. And boom, there that is, right? How long did that take? Snap my fingers, right? I'm going to create the connector, right? And it'll spin here for a minute or two. So we don't have to stop and watch all this. But when your Swagger is set up, it makes this so much easier, so much better. And I think there was a question. Oops, that was Greg filling in for me here. To create that custom connector. I'm not going to make you guys sit around and wait till this is done, but in a couple, oh, there it is. Okay. Well, you can see I got my hooked to my cooling, my auto drivers, right? And once it's done, I can take and say, what if I want to test this stuff, right? Or is it going to work or not? I don't know. I mean, I know because it's going to work, right? But I go over here to code, don't care about that. And I go to test, right? I can set up a new, and you have to set up a new connection. There's my new connection done. And I'm going to say, all right, I'm going to test a cooling failure, right? Okay, well, there it is, status. Okay, get state. I'm going to test that operation. There's my state. There's my stuff, right? And you can see that cooling failed is set to true, right? And in the Power App, I'll show you what happens. But now I'm going to go, all right, we're going to restore the cooling system. Test operation. All right, boom, status okay. We're going to get state again, right? I'm going to test operation again for that. And cooling system failed fault. So you can see all that is happening, right, to the Raspberry Pi that's hosted downstairs at my house. All right, so I'm not actually going to create that connector, but we are going to jump right into the Power App. That is how difficult or easy, if Swagger set up properly, that you guys can make and create a custom connector, which for me is super exciting. So don't be afraid of custom connectors unless you don't have some good Swagger information for that. All right. So now we're going to go into the real-time demo. So I'm just going to go and click on this. I'm just going to load this up a little bit. And the reason I didn't preload this is because there's going to be a warning coming up, right? And it's something that you're going to get when you create a custom PCF control. Right, so you get this, right? Hey, contains custom code. It may not be generated by Microsoft. In fact, it wasn't, amazingly enough. All right, but I'm going to say open the app, right? We're good to this. Okay, and immediately you can see there's data streaming in, right? So there's the live data that's coming in from the custom control. So I'm going to click on this custom control here. I'm just going to show you what happens, right? So on the right-hand side, you can see there's a property, and all I did is I just put this, literally all I did is put this URL in quotes, and put it in here. As soon as I did that, data started streaming in.
Wow.
All right. So
That is
yeah,
amazing, Brent.
yeah, I was pretty excited to see it work. I got to tell you, it was sincerely an aha moment for me. Like, wow, this actually worked.
Can we get a mini round of applause? I mean, this is pretty amazing right here, what I'm seeing in a Power App. I'm going to just give you kudos right here.
Thank you, Greg. Appreciate that.
Of course.
All right. So what's the other half? So data's coming in, but what are we going to do with it? So all there is there's an on-change event. And if you guys are familiar with Power Apps, right, you know that on-change event, when something changes in that control, it fires the on-change event, just like a combo box. If you change the drop-down in a combo box or a drop-down, right, it fires the on-change event. If you have a text input and you change the text, it fires off the on-change event. And all this is doing, again, super simple code, right? I'm taking the data from real-time stream.json data, right? This is the thing that's coming in from the custom component. I'm sticking in a variable, and I could have done all this in one line, but we're trying to do a demo. We're not trying to show how how complicated or compact we can make the code. I parse that JSON into a different variable called var engine. And then I take each one of those elements and I move them into a in-memory collection, right? A table, basically, that's inside the app with each one of these, right? And that happens every second. And then you can see here that every second, right, where this is updating, we have engine temperature, and I'm going to hit the run button here. Actually, I'm not going to hit run. I'm just going to use the Alt key, but I'm going to simulate a cooling fail. And you watch this column right here, this cooling system failure, right? As soon as I click that, boom, within 1 second, suddenly a cooling failure is happening. And notice that the throttle went down when it's suddenly going down, because the way the autopilot set up is, hey, when there's a cooling system failure, you need to throttle it down so the temperature can start dropping. Now, for better or worse, the temperature is not dropping, and I'm not too concerned about that because from a simulation perspective, I don't care. Right, what I care about is data coming in, and down here at the bottom, this is just the JSON that's coming in, the raw JSON that's coming in from the custom component that I created there. Right, so we're still seeing temperatures rise, but I'm going to click on this again. You're going to see immediately, right, and it's cooling failure off, and it is overheated, right? Well, what I'm going to do now is I believe the autopilot it says off, but and I probably didn't set this initially when it came in, but I'm just going to turn it on, and we're going to see what happens here. I'm going to turn it off. Okay, I'm going to hit the play button here, and then I'm going to drag the throttle. Let's see what happens here. All right, so I'm dragging the throttle down to 28%. You can see the throttle immediately drops, right? Drop down again, 6%. Boom, 6%. And let's see, now the engine temperature is dropping a little bit. Yeah, now it's dropping, right? So and our speed is also dropping. The engine doesn't cool very quickly, but that's okay. Overheat. Once it hits at a certain temperature, it's overheated, right? Well, if I want to throttle up, right, immediately throttle up, 94%, and you can see immediately our speed is going. And this segment here, just so you guys know, it's a oval track, right? So when we start going around a corner, when the autopilot's on, it throttles down when it starts going through the corner. I want to take in, I'm just going to clear the collection out by clicking the eraser button here. When the collection goes, right, and it'll stop there. And that's basically what this thing does, right? I turn my autopilot on, and then I try to make a throttle change, I'll get an error, right? See right there, that came in from the API. Right. I could have handled that if I want, but I thought it was super cool that it's like, oh my goodness, an error message actually pops up. I didn't, the API basically is auto drivers on, disable it first if you want to manually use the throttle. So that's another thing about Swagger and the API. If you construct your APIs right, just amazing things happens in the Power App. You can actually surface that. Right here, you can see I just went around another lap. Right, each lap is 5 miles. And 100 miles an hour, we're moving along, temperature's dropping, which is good. And yeah, so that's the exciting part of this. So I guess any question, I'm just going to go through this code again just to show you how simple this is, right? Got the custom component here, right? I simply put the URL endpoint. I got to move my friend here out of the way, right? For my stream, everything happens automatically. It just starts coming in, like data starts coming in magically. And then I set up my on change event to listen to the data that's sent in and do something with that. Now we'll talk about some other use cases for this, some other real world use cases here in just a minute. But I guess, any questions on what you're seeing here?
Feel free to
One quick
come up to
question.
you. Oh, go ahead.
Sorry, one quick question. So in your PCF component framework, right, like how does that it gets connected to the stream URL? Is it being configured into the PCF framework directly, or you have a variable which actually passes through the PCF framework and then it actually reads it from there? Because I understand that you have the custom connector to have the APIs to do the throttling, autopilot mode on and off, and all those things. Good. But how does your PCF actually connects to the SSE stream?
Yeah, I'll show you that. Again, I'm not an expert at the PCF, but I will go through that. I'll show you that right now. But once again, I could take any URL, right, and put it here, and it would start if it had a streaming, an SSE streaming API endpoint. You could bring in any type of data, right, that's coming in. It could be JSON, the other types of data. But let me take and bring that up in VS Code here, and let's switch the projects back over to the real-time connector here. So this is the code that actually does the connection, right? So there's a URL that's passed in, right, which is what we put inside in the component there, right? And then this is just the call, right? It says it's connecting to the URI, and then it's trying it right here. It's trying that particular command, right? Mm-hmm. Did it get connected? Here are the messages. Notify the output has changed. Has there been an error? Right, then catching any other stuff. And I'm happy to share this code with you, right? It's, this is what this is about. I don't have it I have it in GitHub, but it's a private repository at the moment, but I'm going to work on putting it into a different one that I can open up if anybody's interested there. But this is the key routine, right, that connects up there.
Got it.
Yeah, and feel free to take a screenshot of that or anything, like if it's something that interests you, or hit me up afterwards, and I'm happy to, I can zip all this code up into a zip file, or I can give you access to the repository out on GitHub so you can take a look at that.
Brent, once you've got that, Brent, once you've got that GitHub, I can also put it in the notes for the recording.
Okay. Yeah, other stuff there. I mean, there's a couple things, updating the view, right? But that's the key component, because you can see here the initialization process. It gets down here and it says right here, this is the key thing, right? It's just calling if there's a URL, right? Connect this and connect it to the URL, which calls this particular routine right here to do the magic. So, and then I'm trying to think of it's just the URL is just a string. So, it's amazingly simple. All right. When again, I could learn TypeScript and I could do this myself. Right. But it's just my focus is really on the Power App, and I do love Golang as my pro code language of choice, but that's where I did that. So. All right, so I'm going to flip back over the slide deck for just a minute, and then we can see what we can do to make some other magic happen here inside the app. So let me stop sharing here and share the slide deck again. All right, so let's see. So I got through the 4 components of the demo. So what were some of my lessons learned? Right. One is, service sent events works in a PCF, not natively in Power App. So you do have to create a custom component for that. There are some browser-based session limits, so keep alive and disconnect handling, which I really didn't go into around that. I let this thing run for hours, right, without having to do anything to it. when I hit the play outside of the outside of the editor. And the Raspberry Pi can only handle so much load at one time. But, if you're familiar with the Raspberry Pi, there's a very powerful computer running Linux, and 8 gigabytes with 4 cores at 2.4 gigahertz. Granted, it's not a, AMD Threadripper, but, for a less than $100, completing the power supply and all the different things, you have to put that together compared to, $2,500, $3,000, $5,000 just for the CPU and motherboard. It's a pretty good deal. So excited about that. Some of the alternatives that I considered, SignalR, I didn't really look into that. I tried the WebSockets, right? But there's no way to subscribe to a webhook directly from a Power App. You can use Power Automate, but then once again, you got other latency things getting introduced here. And polling, right? You can set up a timer, and I didn't. In fact, I'm gonna reshare again here. I just want to just show you something here, right? So you can see on all the components here, right? There is no timer listed here. I can't remember what I did on the second screen. I think I had another gallery stuff. But once again, there is no timer on this. All this data is just coming in off the real-time stream. All right, gonna go back to the deck again here. One last time.
I liked how you used a corgi, by the way, Brent. It's like me.
I honestly, I lesson learned or something like that, and then there he or she was, I'm not sure, but honestly, yeah, Greg, I did do that for you because I know that put a smile on your face.
Yes, sir.
So there are some governance considerations, right? One, custom connectors in the environments. Not all tenants and IT teams will allow you to do custom connectors in your environment. And so that's something you need to be aware of what your company will allow you to do. There's also, if you guys use GCC or GCC High, the government cloud, there may be additional restrictions on that. And then security at external API endpoints. You need to make sure that you are doing things in a secure way if you're passing any sensitive data across there. I did not put any authentication on my endpoint. Particularly, Jared. Oh, you're okay. Yeah, if you have some comments on that, we can talk about that here in just a second. But anyway, yeah, security is an important thing, right? In any type of application that's available on the web or even not on the web. All right, so real world use cases. What are some other real world use cases where this might come into play, right? So if you think about it, if you have a bunch of IoT data, Internet of Things, in a agricultural market, maybe you have moisture sensors out in the field. Maybe you have tractors that are driving around, or different, maybe bots, right? In the future, right? We're going to have drones that are flying around your field, spraying stuff, picking stuff. Who knows what they're going to do, right? You could actually have the data being streamed into the Power App to look at it, and then have the Power App save that off to SharePoint or to SQL or wherever you want that data to go to. Another example of a real-time use case would be, monitoring a manufacturing facility or a line, right? I can't imagine how much money companies have paid to have a custom pro code application built just to monitor 2 or 3 custom things on a line, right? And you could see that using a technology like the Power Apps we've just demonstrated, in a couple of days, you can get this all up and you can do it super cheap. And yeah, I am using a custom connector, right? So that means you do have to have a license to use this, but I don't believe that the PCF control requires a license. I haven't confirmed that or not, because I know I'm just using the custom connector, which requires a license. In my development environment, it's free. But if you think about it, $20 a month per user, if you have 4 or 5 workstations, yeah, that could be $100 a month of licensing fees. But imagine, compare that to the tens of thousands of dollars you might have to pay a custom manufacturer to, do something for you specifically. So, another thing, financial stock ticker, right? Anybody wants to make their own stock ticker in real time in a Power App, here's a way to do it, right? If you have an API endpoint that can stream data to you, away you go, right? Now you can do all your trading on your own Power App, right? Instead of having to use somebody else's software. Additionally, if you're tracking fleet locations, right? I mean, think about running Uber on a Power App. Well, probably not the greatest use case for a Power App, when you got millions of users. But, hey, if you're just starting out doing a proof of concept with a company, this would be a great opportunity to say, hey, you may need to scale into a pro code solution, but let's try this out for something inexpensive, right? Something you can do for a couple $100 a month or a couple $1,000 a month instead of investing hundreds of thousands or millions around to do that. So, all right, moving on to the next. I guess anybody have any other use cases they could think of where you might want to use something like this to get real-time data in? Yeah, feel free to come off mute or put it in chat. I'd love to hear what your thoughts are.
Environmental monitoring. One of the agencies I support is Environment and Conservation, and they have a fair amount of both water and air emission monitors that are scattered around the state. They have to go through a process of physically traveling to site and transferring USB drives back and forth. They've been looking for a couple of options for doing a little bit more real-time data collection like this. So I may be sharing this concept with them here at some point in the near future.
Yeah, well, so and now you're going to talk about one of my favorite things, right? So I'm not going to spend too much time talking about this, but so this little device here, right? I'm gonna just stop sharing a second to get the full camera on. Yeah, am I sharing? Yeah, I'm sharing my thing.
You're still sharing, yeah.
Yeah, all right. Now stop sharing. Here we go. Stop presenting. Yes. All right. So this is called an ESP32, right? And there's a technology called low raw WAN. It's a low power WAN, basically wide area network. And it transmits stuff in small packets of bits and bytes, but you can transmit miles and miles, right? And this is from a Helium network, basically a different system right here, right? That literally has stuff on here. But I have it's a low raw endpoint, right, sitting out on my deck, and I'm up about 500 feet, not on Scott Mountain, but over the side of that. I get stuff all the way from the other side of Vancouver, all the way near the mountains where you start going up in Kelso, just with one of these. And you can run these for days and days on a single lithium ion battery. So yeah, if you're interested in getting monitoring data out there, yeah, it's super easy to do, super expensive, and super exciting to do if you like that kind of stuff. So, all right.
Helium and LoRa WAN is like such a soft spot in my heart, right? I actually was just sharing like one of the blogs of how Helium is like grown up to even being a mobile network. But for those that are doing IoT and connectivity, like the Helium network is an awesome place to look. And just having, IoT connectivity, permissionless and nearly free is pretty sweet.
Yeah. All right. So, just key takeaways, right? Polling, you have lag, you have cost, you have extra overhead. Streaming's fast, scalable, and responsive, right? And yeah, using PCF, server sent events, custom connectors unlocks possibilities that Dataverse and Power Automate just don't have available to them. So that's my key takeaways on that. And, I'll open it for questions and answers, but anybody wants to stick around a little bit longer and see what we can do to bring this thing to its knees, we can try some real world experiments on this.
Before we do that, Brent, I would love for people to come off mute, turn their camera on. Let's just give you a round of applause for opening this whole world of opportunities around real time and what we could do with Power Apps.